Well, this is the first chapter of the book that talks about the software defined access. During this series, we will have an overview of what is aborded in each chapter of this book. And today we will start with the first chapter, which the title is Today's Networks and the Drivers for Change. This is an introductory chapter because it doesn't go deeper to what the book wants to talk about, but it shows us some of the problems that we have in today's network. What is the expectation of the customers? Where do they want to arrive? And what is being done by the vendors, especially by Cisco, to achieve the goals that suits best for the customers' needs. So this chapter have some subtopics. The first subtopic is networks of today. The second subtopic, common business and IT trends. The third, common desired benefits, high-level design considerations, Cisco digital network architecture, past solution to today's problem, introduction to multi-domain, and cloud trends and adoption. Starting by the networks of today, we see that today's network are increasing, and from time to time it's getting more difficult to manage and maintain the actual networks, because past in the days it was the normal to configure each device at a time, but right now we are living in a world that automation is going to be mandatory, and there is rising some new concepts like artificial intelligence, machine learning, cloud service, virtualization, Internet of Things. These are new concepts that are going to be the norm. So the existing networks, they must have the capabilities to support the ever changing networks, and we can say that the changing of the world, they must follow what the world where the world is going, and with the networks is not it's not different. We must think of the network as one sole thing, and there is a good comparison like a car, a car. The car have many components. It has the chassis, it has the seats, the battery, a lot of things. But what we want to achieve is to go from point A to point B, and with the network it's the same case. What we want to have is to have a single pane of glass of all the infrastructure. We want to have a clear goal of what we need to our network, and to give some specific command, and independently of what we have underlined, we want to achieve the goal that we are supposed to achieve. Passing to the next topic, business, common business and IT trends. Well, there is a lot of trends in the IT, like the adoption of the cloud. There is some big vendors that offer cloud services. There is public, there is private cloud, there is the bring your own device. So there is a lot of things that we want to have in our network. What the user wants, the user wants fast network, less bandwidth. Good user experience. We must assure that the new networks can achieve the goals that we want and specifically what the business needs. Good network, lower latency, capability to do calls and videos without many interference, good internet connections, and that is the things that we in the business really want to the next part. What are the benefits of the common desired benefits? What are the benefits that they want to have? Lower cost. Everybody wants to reduce the cost of the network. The complexity to operate the network. We are living in a world of the automation. We doesn't need to do everything manually. We want it to be automated, simple to troubleshoot, uh, fast communication. That is what the desired benefits that they want with the network. And there is a lot of things involved in this. And one of the things is the redundancy. And this redundancy perspective is to avoid the downtimes of our network. That's why we are coming to the fourth point or subtopic, that is high level design consideration. Normally, when we talk about the redundancy, there is two way of doing the redundancy. First way is by the links, having redundant connections. If we have one switch that connects to a service provider to the internet, we don't want to have a break here and affect the users. We want to have a redundant connection to another internet provider. We have internet provider 1. Even if the internet provider 1 is down, we have another provider. Even if this switch is down, we want to have two devices connected to the providers also. In that case, even if the switch is down, there is another switch providing and guarantee that the network is always active and available for the users. Passing um, to the next point is Cisco Digital Network Architecture. This is the DNA. Normally we see the DNA. DNA stands for Digital Network Architecture, and Cisco is working very well to achieve the goals that the people want. What are the goals that we mentioned? Instead of being hardware centric, we want software driven. If we have software driven, we can automate more. We can do programmable. We can do predictive to know when the problem is going to happen. We want to do business intent. We want do business intent. When we talk about business intent is, well, today we have a special session in one of our business unit, and we want to guarantee that this business unit has the priority over the rest of the network. Defining what we want, it must be easy to configure the network to achieve the goal that we want. That's what we talk about the business intent. And the DNA, the digital network architecture, they want to leverage this thing, the business intent, and to convert this in what is going to happen in the underlay. Past solution to today's problem. There is many problems that the today's network faced. One of the problem is spanning tree. I would not say one of the problem. One of the solution was spanning tree. What was the goal of spanning tree? The goal of spanning tree is to guarantee that we doesn't have loops in our infra. Let's say that we have a pair of switches, access switches, connected to a pair of distribution switches. In this case, we would have loops in the network because there is different paths and we have layer 2 connections. The distribution switch to each of the access switch, and there is another distribution switch to each of the access switch. If we have a pure layer 2 connections, it would not work very well without the spanning tree. What does the spanning tree does? It blocks some of the interfaces in order to not have loops inside our network. You see? What is the problem with the blocking some interfaces? Is that it's going to limit the total bandwidth that you have. For example, if you have 1 gig here in the first link and 1 gig in the second link, you would expect to have 2 gigs of uplink. But if you are blocking one, you are going to be limited to 1 gig. That is one of the problems of the spanning tree. It comes to solve an issue, but it brings another one. Even with the layer 3 connections, we are going to solve this issue of the spanning tree of the network, but it would create another problem. You know, I'm not going to go very deep because it's going to take some time, but the problem normally is if you have one user here, as long as we have a layer 3 connections, if you have one user here in one VLAN, you would have another network or subnet here, and it will be resource intensive to configure the same policies of this subnet has been the same on the other one. If you are in one department, for example, and you go to another place, you want to have the same level of access. It would implicate configuration done by the network admin, and the problem is time-consuming tasks. How we can simplify this? By the modern network residing on software-defined configuration. Going to introduction to multi-domain. Cisco offers various scenarios and various solutions for this. Software-defined one, to define software in the one connection outside to the network. We have it in software-defined access that we are going to explore further. It's inside of the campus. We have the ACI to guarantee the connection of our data center and to be able to assess all the resources that we need to perform our activity. Cloud trends and adoptions. The cloud trends are being more and more adopted. There is, for example, the software as a service, the infrastructure as a service. Here we can say adoption with the Google Drive, Salesforce, and others. We can have our infra as a service using Terraform and other providers. So we want to have a way to do it very efficiently without many problems and less complexity. That's why the networks must achieve the goal of doing what the business want. That is the overview that gives us the chapter number 1, and for today it's all, and in the next session I will talk about the chapter number 2.